Hi, everybody, and welcome back to the Bat of Doom track for the afternoon technical program at virtual Kernelcon 2020. The first talk this afternoon is a full talk by Sam Curry. Sam's got lots of experience in bug bounty programs and occasionally comes out to the local DEF CON meetings and enlightens us on all the cool stuff he's got going on. So he's currently at 17 Security, and he's got some pretty interesting stuff about secondary contexts and web applications. So I think this will be a pretty fun technical talk. Please get your questions into the Bat of Doom channel on Discord, and I'll proxy him over to Sam at the end of his talk. All right, thanks. Off to you, Sam.
Cool. Yeah, so this is attacking secondary contexts and web applications. And to give a preface, secondary context being like APIs, middleware, kind of just like the in-between. So let's get into it really quick. Let's see if I can get my tools working. So yeah, to kind of start this off, I think when I got started with web stuff, and I think when a lot of other people got started with web, you're kind of introduced to hosting like an index file or PHP and like a web root or something, and that's where all the files are accessible at, and then users would browse your website and access it via /index.php and load the file in. It was all really straightforward, right? You've got like directories, you've got files, and up until as of more recently, it's kind of like how I just assumed everything kind of worked. But with modern stuff and like with everything moving towards more complicated frameworks, you've got like a lot of server-side JavaScript and like these particular types of routing. You've got just like really, really complicated ways of, or more complicated ways of doing routing. So instead of having actual files, you have more so routes, and even beyond that, you have proxies into routing, and these just like more complicated middleware and routing functionalities. And then here's a couple examples, just going through this. This is just an example. I think this is Apache for essentially proxying requests to actually entirely different servers. So where you think, where at least I did when I was younger, thinking like hitting /images just loads in a directory like /images, it's actually being forwarded to an entirely different host instead of just like a folder on a box. And this is just a really interesting behavior. And up in the right corner, you've got, for instance, even certain extensions being forwarded to a different proxy, or like certain directories. And I guess this gets into just more examples of how not everything is as straightforward as it seems. So for this example, you've got fetching responses from APIs, where, for instance, just a really simple get parameter gets passed into an API, which is an entirely different server, and then it retrieves information from that and passes it back to the original server. And a lot of times it's like a second host or like an internal host. For instance, if I'm an organization and I have www, I'm also going to have like api.company.com, which is only internally accessible and used in the context of maybe like a library or like just an API that's used for something like, for instance, user authentication, right? So with where everything's going now, with these like multiple points of access, you've got like analytics dashboard, you've got like your actual core application, having like a single interface for authentication. A lot of times it's more beneficial to have that like underlying API that's just used for all of the user services. And I guess, sometimes querying authentication information into that internal API makes it a little bit more complicated. And I guess this is where we get into just like actually trying to identify how applications do routing. From a perspective of like bug bounty, let's say, or like doing an application pen test, where it's like a black box test and you really don't know what you're looking at, it's really oftentimes pretty difficult to identify if an application is doing routing. Now, if you look at like the previous example where something like get/images actually takes you to a different vhost, if you're able to identify that it's actually forwarding you to a different host or a virtual host, then there's like a lot of really interesting functionalities that you can explore. I think a lot of people here may have seen a lot of like directory traversal type attacks where you're able to like traverse downwards and read information. In a similar sense, you can, let's say you're being proxied, like get/images loads in like another vhost/images. you can actually like traverse downwards. And instead of traversing downwards on that original box, you'll traverse downwards on that second box. So here's just like a lot of methods, I guess, for identifying if an application's doing routing. And kind of the first one is just directory traversal. If /API ... returns something different than the get slash on the initial application, then there's actually a really good chance that like it's being routed to a different host or just being routed to like a different directory. I guess secondly, there's just throwing in control characters. If you throw in like a question mark, ampersand, a hash, period, slashes, and there's a different behavior, or even nicely enough like stack traces where it's like, hey, I'm unable to load this, or this is giving a 400 bad request, so you can actually see that internal HTTP request. And then again, if /images behaves differently than slash, or again stack traces. Now here's just like a really quick example of something that you can kind of identify. Of course, www.yahoo.com isn't actually hosted on CloudFront, but /favicon.ico is actually being proxied to CloudFront. And this is something you can observe via, you hit /favicon.ico, loads it totally normal, and then you add some stuff afterwards, and it gives you this access denied error. And this is just really interesting. It's not necessarily exploitable, but at the same time, if it were something different, we could maybe explore it more. For instance, an example attack we could try here would be, get /favicon.ico, // and then user controlled bucket. If, for instance, this were being served over S3, and then you could just load in, your cross-site scripting that you host in your own bucket. But this is just a kind of a more hypothetical entry to what could possibly be going on and just how to explore that. And if they'll go forward, we'll see. There we go. And here's like a second example here really quick. If you send a request to the web root of this application, it responds totally normally. It's just like any other application, like let's say like a corporate website where it just gives you the who's here we are, or this is who we are, and this is our yada 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 normal application. But when you browse to /API/v1, the behavior changes entirely. You've got that JSON response body, like please insert a method, and it's just like a different application, you can tell, or different behaviors. There's different headers, the content type changes. And you can actually confirm that this path in particular, /API/v1, is being routed to another virtual host or different host. And you can actually go down in directories on that second host. I guess to explain this a little bit more clearly, and this here, /API/v1 groups, the server recognizes that. The initial server recognizes, hey, this is a route that we want to go to, and this route in particular is going to get forwarded to this host. And once you're at that other host, everything after that is sent to that other host. And then this is where we supply, the 3 directory traversal characters, and we're able to actually traverse to the web root of that second host. And here we can see that host responds with just like a page with methods that you can call. For instance, /application status, statistics. There's a bunch of just bindings for like kind of interesting information that you wouldn't see on that initial host. And a lot of really fun examples. A lot of times when you're being forwarded to like an internal host, the people who've built that application don't expect you to be able to freely pick the path that you want to go to. They don't expect you to be able to traverse out of certain API calls. So that box is going to be sometimes a lot more interesting. For instance, /server status is a lot of times accessible. There's a lot of times, debugging and testing functionality and things like that you would see. And this is just another example of how to actually identify that and just something interesting you can pull. And here's like just like some common issues with those secondary contexts. Data is being served across different layers. You've got that initial routing, like if you hit this URL, you're going to get forwarded to this URL, and it's actually that server sending that request, and it's carrying all of your information. So when you've built up this entire secondary box and this initial box, and you're sending the data, you've got the user sending the data, and then the first box sending it to the second box. There becomes a lot more issues with being able to control that data for what is actually valid stuff. Let's say your first box takes a new line character, %0D, and it's like, okay, this is a totally normal character. It's nothing strange. But when it gets converted into that second box, it URL decodes it, and then you've got CRLF injection on that internal box. Developers now expect you to be able to control parameters. This is another really interesting one that you'll actually, I think it's more fairly common. But a lot of times when you're being shot into the context of like an internal API, a lot of times it's in like a HTTP GET parameter, where it's like $ID = 1. And developers don't really expect you to be able to do, %26 and do an and symbol, and then, throw your own second parameter. An interesting place I saw this actually one time was you're able to forward in extorted 4. And if you did like your own like, DNS bin or burp collaborator, it'd send a request to that IP address and you could see that DNS lookup. But what you could actually do is actually add like an and sign afterwards and then declare other parameters. And it was blind except for DNS. So you could tell that, it was doing a DNS lookup. And one thing you could do is you could guess that there's the parameter that they're using in that second context is IP. So if you did, like DNS bin and IP equals DNS bin again, it would actually concatenate the two strings and then send a request to HTTP or the address 1, address 2, and you can kind of understand how the application was behaving a little bit more. It wasn't actually exploitable, but it was just really interesting. Information disclosure is really common. A lot of times, like these internal APIs or secondary contexts will have like these global administrative keys where you've got like if this request is being sent internally, just use this authorization bearer, and that's what we're going to use to access it. But that leads into, well, what if I'm able to pool someone else's information, right? Like let's say it's an authentication API or a user information API. You can actually retrieve information about other users if you can get their request right. And lastly, just server-side request forgery and cross-site scripting, if you're able to like manipulate that response content. A really fun example is if you're able to identify open redirect on that second host, that API, then it's being sent within the context of the server. Because you've got the initial request being sent to that first box, and then that first box is what's actually sending it to that second box. So if you're able to get server-side request forgery, it's being sent in the context of the web server. So lots of really cool stuff there. And then Google Slides is being a little slow for me. Let's go back. Here's just like another example of just identifying application routing. So you've got this endpoint get/files, and then you can declare your file name, and you can only access this if you're logged in. What's really interesting is that when we supply %23, it gives us this really, really nice stack trace. And it says, hey, we're not able to read this file, and then here's how it's working. And you can see there's just like /db/users/id/uploads/lol.png, where we're only sending lol.png with %23, which URL decodes in that hash. And this, we can kind of ask questions like, how could we exploit this? Like, what sort of things could we try? And one thing to notice kind of immediately is that like 9283 is a unique identifier, and it looks like it's a unique identifier for the account. So if we could maybe traverse downwards and overwrite the user ID, we could potentially access another user's files. And that would actually look like this right here, where if we do, move this out of the way for me. If we go ahead and traverse downwards via just %2f, we can see that in the API call, it traverses downwards. There's no more lol.png, and it goes downwards 1. And then we've also just got that hash in there to cause the error. And if we go forward one more, we can actually see, we can actually pool another user's file. If we're able to identify the user ID of another account and then their file name, we can pool that upload from the other user. So via just identifying that stack trace with a %23, we're able to determine that it's being indexed via user ID, and then we can traverse downwards 2 times and then just put in the other user's file and load their private files. So this was a really cool find, and it was probably one of the most clear-cut cases where you're able to say, oh hey, this is how this application is like routing, and here's how we can exploit it, because everything is just very straightforward with that error message. So yeah, this is just really cool. Oh, and yeah, all the other API calls would be accessible as well. What's really nice about this one is there are other API calls that we can hit on that internal API. Serving files is one part of it, but there's just other kind of nice things that you can pull. For instance, like there's semi-information disclosure about other users. You get things like email, first, last name, and there's different things like that. And actually, just exploring that is actually, it's kind of the same process you take. If you're running dir search against some host, it's sort of the same approach, except URL encoded, where you can just dir search this host, as the responses are so clean cut. Yeah, this was just a nice one. And here's, I guess, going into like common issues with attacking secondary context. A lot of times, the first one, I guess, is a lot of times, even if you are able to pass in that %2f or /, APIs don't really normalize URLs that well. So a lot of times it's going to be like, hey, I don't have a matching route for OAuth2/request/auth/./ and you're like, well, that's not what I'm trying to access. I'm trying to get to go backwards. But then API is like, yeah, but I don't want to go backwards because I'm not really, that's not my thing. I don't really ever run into cases like this, so I'm not going to go do that. So here you can see, there's one case of OAuth2 request auth not really doing much, and then the second one is just saying, hey, I can't find this API call where it traverses downwards, and then you try to restate the API call. So you could do API calls afterwards, but you can't traverse downwards, and that can be an issue sometimes. Another common issue. A lot of times, even though you're talking to that internal API or that secondary context, they'll still have authentication models that are exactly the same as their normal application. They're expecting an authorization bearer, or they're expecting your cookies, and then they'll do something with those cookies or authorization bearer to determine whether or not you have access to that requested resource. And this is just a normal issue that you're going to run into. It's very sad. We've got this Stack Overflow, so I'm explaining how to pass in cookies, through the vhost to that second URL. And here's a kind of just diving into another example. Here's an example about a couple years ago, I think, on a Luminate, which is like a file hosting or like a web hosting service that Yahoo has. And one of the really interesting things is you've got this endpoint where you can load your invoice, and when you click the URL, it's going to load like a PDF of your invoice. And one of the first things I tried is like, well, let's just change the ID, see if we can pull other users. But interestingly enough, it would respond with 404, which can sometimes make sense, but in this context, it didn't quite make sense. So I kind of explored this a lot further, and one of the first things I tried was get my services invoices, %2f invoices %2f, and then that invoice ID. And what I was aiming for is just trying to identify whether or not this was being routed to like an internal host or if it was like just normal application behavior. And one thing I did notice is if you traverse twice and then tried to just call it regularly, it wouldn't work. It would just fail and say, 404, this doesn't exist. But if you traverse once and tried to load, /invoices, you could tell it works. So it's like, this is kind of weird in the sense that if it were just behaving normally and we're like a normal application that's normalizing URL, then I should be able to hit it both contexts. But the first one works, the second one doesn't. So maybe invoices is a directory on a second host. So I kind of explored that a little bit further. And let's see. Google Slides is killing me. Yeah, just so there's a possibility invoices is indexing our uploads. And let's see. One of the things I kind of thought of is in the previous context where we had that routing, where we're able to pull the other user's files, maybe we could do a similar thing here. But the question is, how do I identify how it's indexing our folder? So the theory is that after looking at this, there's a second host with before /invoices, there's some index for our user account where we're able to access the invoices. And this is just pure guesswork and mostly wishful thinking on my part, trying to identify what's going on. So I kind of just theorized this and moved forward. And a lot of things I tried, like running through Intruder, maybe there's user IDs and maybe I can just pull my invoice eventually if I get it right. And I looked around the application for a long time until I finally saw this error message where it says ID samwcurry@gmail.com, hash VJ does not have permission to modify example.com. So I was thinking, okay, that's kind of weird. Why don't I just go ahead and try this to see if it's indexing here? So I went forward and actually did that, and it worked. So I was able to identify that this service was talking to a second service, which had indexed my account using my email and some weird VJ string afterwards. And from this point forward, it's like, okay, so how do we actually exploit this? Because what we'll need is, a victim's email address, and we'll also need the victim's invoice ID. And I was like, this bug kind of sucks, to be honest. Like, sure, you can like brute force this, or sure, you can target specific users, but it's kind of whatever. Maybe there's like the same behavior somewhere else in the app that's more interesting, or maybe it's exploitable in some other way. So I kind of moved forward and looked through the app a little bit, and I saw this where you can access payment methods, and this was just kind of really interesting off the bat. And I was just so curious about how they were doing this. But if they had like such a weird setup for that invoices thing, maybe they have the same setup for this. So I went and explored this, and I ran into this parameter right here, where you can control the UID. And I kind of looked at this and was like, okay, this is definitely not predictable. It's this long, unique string, and there's probably no way I can view this. You send this HTTP request, you can load the card information for the user, and it's like, there's not much I could do here. But I did try, making a second victim account and then mess around with it a little bit, trying to load it, and I wasn't able to really get anywhere with it. So I kind of took a step back and went to like other portions of the website. And I found this. I did identify that you could traverse backwards, and the directory name was payment methods. So it's doing the exact same thing, where it's being stored on like a second API call, and you can access it via /payment methods. So it's like, okay, cool. So we can do the same behavior here, but how are we going to be able to retrieve this unique ID for the payment method? So moving forward, I found this other endpoint where you can pull people's subscription IDs, or you can pull information about subscriptions. And inside of that, there's a string that contains that token to access the payment method. So I was like, okay, this is easier to guess. The subscription ID is only like 6 or 7 numbers, and you can just run it through Intruder in like 2 or 3 minutes. So it's like, okay, so if we go ahead and have this initial request, subscriptions, and then we traverse back twice, and then we add the victim email address, and then we brute force out that ID, we can actually pull their payment method strings. So I went forward with that, and I was able to pull payment method strings of other users. And that final call to view other users' payment information is just traversing back 2 times after pulling that payment string, and then hitting /payment methods and then that ID. So this was just a really fun case of identifying like a secondary context, some API or maybe some sort of like file store service, and being able to blindly kind of gain information about it through just messing with the app a lot, and then being able to exploit it in this kind of fun way at the very end. So just a really kind of clear-cut case of where this is applicable and kind of a neat bug. Oh yeah, and then of course our very happy smiley face guy with the money from the bounty and all that stuff. Celebration, you can pull other people's stuff. It's a crazy bug. Not really. You did a lot of brute forcing and prerequisites, but it was a cool case. So yeah, moving forward, there's a lot of kind of interesting possibilities with this. In the same sense, a lot of times API calls can be similar to like SQL queries, in the sense that we're trying to get it to evaluate to true or false. For instance, like one of the most common ones is like user authentication. If we have like /users/123/private data, and it takes that 123 and it makes that request to like /123, does user have access? And if that returns 200 okay, then you're good to go. If it doesn't, then you can't view that information. And I've actually seen this on like a couple apps. One of the ones like primarily that I'd seen like similar functionality was Atlassian. A lot of their products had kind of a similar like user authentication service that was kind of interesting to explore. So I guess in the same way that one person will like tamper with a SQL query where you're trying to inject or 1 = 1 to get it to evaluate true, we can actually explore this in the sense of getting an API call to return 200 okay for trying to access protected resources. And of course, the impact varies like per case. The one thing that's really interesting about all this stuff is that nothing is very clear-cut or straightforward, and most of the time it's kind of libraries or developers like custom implementations or them building out their custom libraries. So you do see a lot more bugs where you have to be more thorough, and if you're more thorough, you kind of exploring just a lot of strange possibilities and a lot of just weird guesswork. But one of my favorite cases of this was actually a write-up by a guy named Igor, and it was for this service called Authy. And Authy is just like a 2FA service. They provide like the host and the actual functionality to do 2FA codes, and then you just throw in a library and API key to your web app. And you've got the user talks to the, for instance, in this case, the pictures from the Pinterest API. User talks to the Pinterest API, gives them username, password, phone number, and then Pinterest calls Authy and it says, hey, this user's trying to log in my site. Can you send them a 2FA code? And the user gets the 2FA code, puts it into Pinterest. Pinterest sends it to Authy, and then they figure out whether or not the user should be able to access the site. And it's a very kind of interesting case where you control information that's being sent to that secondary server, which is Authy. And the kind of crazy thing was that Authy's only check was that, or Pinterest in this case, the library Pinterest was using, the only check for that API call to verify your code was whether or not it returned 200 OK and a JSON success true. And you kind of expect like, okay, that makes sense, I guess, but how does the user actually send that code? And what's interesting is that the user's code is sent in this GET request where they actually get to control a path. So you can kind of guess a little bit of what the user would send in order to get it to trick it to return 200 OK and JSON success true. And since you're able to control that full path that's actually sent off to Authy, you can find any other API call that returns 200 OK and success true. You can think, for instance, things like /ping where it would return something similar or things like that. But in this case, it was actually move forward. We'll see. Come on, Google Slides. There we go. Nope, it's too far. We'll see. There we go. Yeah. So the solution for this was just sending /SMS, and it was a universal 2FA bypass for a huge portion of Authy libraries. And it just shows you kind of how simple these bugs can be when you kind of think about them a little bit. And that's kind of one thing that's more strange to me is these bugs aren't necessarily automatable outside of directory traversal. You could set up a script to determine whether or not the information you get back from like /images is different than /, and if so, is the information you get back from images .. different from /? Then you've identified some sort of routing and some sort of potentially exploitable routing. You could maybe code something like that. But in this case, it's kind of just trying to work through the application and understand the functionality. If anyone were to look at that library, they could see here's the condition for it returning true. Here's where the user has input and determining what response. And if you put one and one together, you've got this crazy 2FA bypass that is just like super, at the end of the day, it looks so simple, right? /SMS, but there's just this whole process to figuring that out. And it's just very, very, very interesting. And yeah, huge props to Igor. That was an awesome bug. And I guess just to review, at the end, there's a lot of really unique opportunities in attacking these secondary contexts. I didn't really go over too much here, but there's a lot of really interesting, the communication between that first and second server can oftentimes be really confused and muddled. And you've got like these issues of translating strings. I did a write-up about a year ago about this bug where you could essentially, on the first box, if you passed in like a null byte, when it got passed to that second server, it kind of like didn't know what to do with it, and the string length was off, and it would just spit back a bunch of information back to you. And it was like a buffer overflow or memory corruption. I forget the technical term in that specific context. I'm terrible at nitpicking those, but you could actually just dump tons of information from the server, and it was because of a fundamental misunderstanding between that first and the second server. And it introduces all these unique possibilities of just, you've got this whole firewall, you've got this WAF on the first box, and it's like, we're going to stop like all the bad requests. But then if you WRL encode something and it gets passed to that second box, and then that second box has to evaluate it instead of that first one after it gets decoded, then maybe you've got a chance to do cross-site scripting or something. And I think this is actually where like a lot of these like you'll see these payloads everywhere where it's like this is triple URL encoded, or this is like some sort of other weird encoding. And I think a lot of times some of the reasons behind those are actually because they're assuming that the data is being sent to like an underlying server box. Yeah, the requests are often sent internally. You know, you've got those internal APIs that are just really, really interesting, and developers and people don't really expect you to be able to do fully fledged calls. You'll see a lot of, you know, like / server status, and where you can dump like, you know, internal requests, and these endpoints you typically see on like an internal environment. They're often like really less restrictive. Yeah, kind of went over that already. Authorizations sometimes seemingly arbitrary, you know, 200 versus 403. Like, I don't think you should be, you know, checking an HTTP response to determine whether or not, you know, someone has access to a resource if that user can control, you know, the entire path. It just seems kind of crazy to me, and that's where like a lot of those vulnerabilities arise. It's a very, very complicated problem for developers. When you're like 2 levels deep in an environment and you're dealing with, you know, somebody else's library for talking to like an underlying box, then it can be kind of like a hard problem to solve. It's really hard to isolate internal APIs to the point where the user data isn't dangerous. If you're relying, you know, for instance, on a user to only be able to write within a certain Git parameter, then, you know, having to encode that data where they're passing on like a regular string is kind of difficult, especially when, you know, do you, for instance, would you sanitize the first one? Would you sanitize the second one? Where would you do the checks? It just gets kind of weird. And I guess lastly, there's like a lot of kind of really cool research coming out that can be used and applied to this. One of the really recent ones is an Agari blog post about this max forwards header, which is really interesting. And it's basically this header where the server, if it follows it, then it will only send the maximum number of HTTP requests or requests internally, right? So like, let's say it's going down like 4 boxes, right? And you have a max forwards header set to 3, and you send a trace request. It'll go forward up until the 3rd one and then stop. So you can kind of use that to identify like how many layers deep are these and what information can I get about each box on the way down. So I guess moving forward in the future, there's just like a lot of really interesting, you know, new areas of research that are coming out kind of relative to this, and there's a lot that can be applied to it. But yeah, just it'll be interesting to see where if this particular kind of area has more research as these organizations build these, you know, internal toolings and things get more complicated. But yeah, that was just exploring, you know, attacking secondary context. I think we're a little short, so I'd love to be able to answer some questions you guys have. Just general anything. Yeah, thanks so much, and hope that went all right.
Yeah, I think so. It looks like we got a couple of questions pinned up. One is sort of somewhat of a question directed at Sam and how you allocate your time and stuff. What percentage of your time do you spend exploring secondary context versus, you know, other classes or other things?
I spend a lot of time, like, for instance, a lot of my bug hunting stuff, like, I'll spend time like exploring like really weird stuff, and I think secondary context like falls into that weird stuff. So I'd say about like 50% of the time I'm hunting, I'm looking for like that one kind of interesting behavior. And I think secondary context like falls into like kind of my methodology for finding weird behaviors. I was actually hunting with a couple people, and like they were kind of laughing at me because I was trying like these really weird things with this, and I actually found the bug. And like I'd spent like 5 or 6 hours the day like exploring this really weird. There's like a JSON body, right? And you had this string in the JSON body, or you had 2 inputs in this JSON body, and like one was URL encoded and one wasn't. And like I spent all day trying to figure out what was going on, and it was actually being inserted, like interplaced into another JSON body that was being sent to an internal like API. And what you're able to do is like escape the context of like the JSON parameters. And yeah, basically like whenever it comes up, I'll put a lot of time into it, I guess, is what I was trying to say.
Gotcha. But you, I guess you don't, not quite sure how to say it. You don't really have like a queue of like 100 things that you know you want to look at someday and then like prioritize the secondary context ones or anything like that?
Yeah, no, not particularly. I think it kind of falls into like kind of, you spur of the moment, like what do I feel this application is doing, and if so, I'll go ahead and explore that. I think like the best way to answer that would probably be like no, I don't necessarily have like a checklist, but like yes, I do allocate like a bit of time into like figuring these out, if that makes sense.
Sure. Yeah, that makes sense. Definitely, it's just kind of like one of the things that when you happen across it, you sort of the key is to sort of recognize it and then know that you need to pull a little harder on that thread.
Yeah, exactly.
Yep, yep, cool. Um, I, I'm not actually sure how to reformat this question, so I'm going to ask it like almost exactly as it's typed. But how do you build like the proverbial you? How do you build a web app that can avoid these issues?
Yeah, I think one thing is just like maintaining a good line of like understanding like how data is being sent and being able to identify like these points where it should be filtered and like for instance, if I have a team like working on like a front end application that talks to these like back end applications, and the two teams are kind of like distanced from each other, there should be really clear understanding of like when it comes down to it, like this is should team one be set to like really control what data should be sent through, or should team two be in charge of really filtering out that data? And I think being able to like have a good clear line of communication for identifying like where input's coming from, and at the end of the day, like just what should be available to that, then I think that's probably the best approach. But like more straightforward is just like if you can limit something to a number, limit it to a number. If you can take out certain characters, take out certain characters. Really understand and like spend a couple days like trying to figure out how your application deals with things like %2f. Like when that gets down to like my internal API, is that being evaluated as a slash, and can I like traverse backwards? And if so, then that's kind of something interesting to explore. Yeah.
Yeah, that makes sense. I guess when you're analyzing these sorts of things and you're trying to understand the other side, right? So you're talking about when you're building it, you want to really understand what happens with that input and how to sanitize it and how to make sure everything's safe. From the flip side, when you're trying to decode what the developers had, what choices they've made, what tools and processes are you using? Is that sort of like a burp suite thing, intruder, or something else?
Yeah, burp suite and intruder. Like most of my testing with this stuff is pretty much always manual, because it's always so weird. Being able, I spend probably too much time. Like if I ever see like 400 bad requests or something, like it's like, okay, this is kind of strange. Like let's explore this further. And most of the time, it's just always manual. Otherwise, it's kind of intruder with like a word list. One example I think automating makes sense is like if you're able to traverse down directories onto what you assume to be a second box, you can go ahead and just knock out like a dir search and just see if there's any files that are accessible that normally aren't accessible. And if that's the case, then I guess thumbs up. You found something sort of interesting.
Right. Yeah. Cool. Can a random token be used for authentication? Would an asymmetric scheme be best?
I'm really not sure what would be best, but I think that like if you're going to make this like as locked down and secure as possible, like if you had like a token or you're signing that like initial request that's being passed down, I think that makes sense. I wouldn't necessarily think that you would have to go like as far as having like an asymmetric scheme or like some crazy crypto stuff, but more just if you're able to build that, in the previous slides, you've got that underlying authentication model. If you're able to apply, that same authentication model and authorization model to that internal API, then I think that's what makes the most sense. I don't really see it, basically like I think the end goal, right, is to treat, if a user has the ability to input information onto that second API and they can kind of control stuff, then there should be the exact same limitations that would be applied to that initial that public facing box. So I think that's sort of the approach that I would have.
Gotcha. Yeah, there's a lot of folks, putting clap emojis and saying great talk and stuff that you can't see. You'll have to go look at that later. But yeah, it really was a good talk. Thanks. Always nice to do like a little deep dive on a topic with you, Sam.
Cheers. Thanks, yep. Sam.
So you're watching the Bat of Doom track at Virtual Kernelcon 2020. and we'll be back for another technical talk after a short break.
Awesome. Thank you, guys.